Had no need to fight tonight.
Few problems faced by solid waste management such as arriving at the residential area on time. This delay will cause the residential area to smell bad and create an uncomfortable environment. Next, data for travel time from nodes to nodes is collected and obtained through Google Maps to apply the Dijkstra'S algorithm. By using the Dijkstra'S algorithm method, minimum travel time and the shortest route was obtained. The shortest route distance is calculated by manual calculation and also using Excel solver in Microsoft Excel. So, what is solid waste? Solid waste can be characterized as unreusable things caused by human activity. Solid waste has a mass, weight, and constant volume. Municipal solid waste, which is MSW, can be classified into different sources. These include waste from residential area, institutional locations, industrials, and commercial center. MSW consists of everyday items such as tire, metal drum, glass bottles, and food packaging. Insanity condition due to inappropriate disposal of MSW could lead to environmental pollution.
Problem statement. The rise in the quantity of a solid waste in developing countries gives a serious negative environment effect. Improper schedule of a solid waste collection can cause the unpleasant smell to residential area. This is due to the large amount of a solid waste accumulated in the residential area. Increased operating costs where a solid waste management has to hire many employees to complete the task involved. So proper schedule for the solid waste collection has to be designed to solve the bad service problem. One of a method can be used to find the shortest route for the garbage truck, which minimum travel time is a Dijkstra'S algorithm. However, the current use of DA neglected the road penalty. Therefore, in this study have improved the method of DA, which will consider the road penalty to find the shortest path between two nodes in order to collect solid waste from house to house. In this study, there are two objectives need to accomplish, which is the first one is to develop a travel network for the waste collection in selected residential area in Sumatiga. Second, to find the shortest route with a minimum travel time by enhancing the basic Dijkstra'S algorithm.
Significance and benefits of the project. The findings of the study will benefit everyone, including the society, government, and waste collection company itself. They will receive benefits in terms of hygiene and clean environment. In addition, the government and the company will get extra benefit in terms of cost. The government does not need to pay extra money to the related company, as there is no additional cost from the company. Moreover, this study can give benefits for future research. More literature can be included in the study, and academicians and researchers may have a better understanding and completely understand how the program operates. Scope of the study. This study focused on finding the shortest route with minimum travel time of solid waste collection by using the Dijkstra'S algorithm. Only travel time is considered in order to collect the solid waste. This study only covers a solid waste that will be collected within working hours. The aim of this study is to find and use an effective mathematical model and to estimate the shortest route with minimum travel time for the collection of waste.
The Dijkstra'S algorithm are the most common variants to solve the shortest path problem. The shortest path algorithm focuses on road length and determines the shortest road between the nodes, and the fastest path algorithm concentrates on the path with the minimum time of travel. The main advantage of this algorithm is it can be applied to estimate the shortest route with some assumptions. This is related to our study, where we applied the Dijkstra'S algorithm with some assumptions. This algorithm has a wide range of applications such as multi-point routing, survey and mapping, logistics and transport, and highway tools. For example, a research done by Samah, Basari, and Hussein, where they using Dijkstra'S algorithm to find safest and shortest path during emergency evacuation.
Basic idea of ACS was inspired through the observation of swarm colonies, specifically ants. The advantage of this algorithm is it can adapt to changes such as new distance. Besides, it has been applied to a wide variety of applications such as traveling salesman problem and vehicle routing. Genetic algorithm was developed in the early 1970s by John Holland and his colleague and are influenced by Darwin's theory of evolution. The genetic algorithm is based on the genetic structure and behavior of the chromosome of the population.
There are several types of software platforms that help build and simulate models. In 2017, Abdullah and Ken Hua used a simplex linear programming in Microsoft Excel in the application of shortest path and maximum flow with a bottleneck in travel flow of Kota Kinabalu, while Vasilev solving the traveling salesman problem with the all different constraints in the MS Excel in 2016.
The methodology consists of three main phases, starting with data acquisitions. For the second phase, a travel network was developed from the maps in order to collect the solid waste. And the last one is, in the final phase, we use the travel network to find the shortest route with minimum travel time.
The first phase in this study is a data acquisition. The maps of this study are obtained from a Google map. This map was taken according to the area under study, which involved some residential area in the Serban 3 Negeri Sembilan. Road penalty will be considered, which is, in this map has a 15 residential area and include 9 road penalties such as a roundabout, junction and traffic light. Assumption in this study: first, taken on the normal working day of around 7 to 9 hours. Second, the speed limit of the handling of garbage truck follow the speed limit set by the Department of Road Transport. Third, the garbage truck is in a good condition, and fourth, the garbage truck is free from the accident, and so on. Okay, phase 2 is a developed travel network. From the map, we develop the travel network that include all node and travel time in minute that was used in our study and replace each of a residential area to a node.
The shortest road distance is calculated by manual calculation in preliminary study and also using Excel solver in Microsoft Excel for actual data. Microsoft Excel solves a wide range of tasks. Using Microsoft Excel is more accurate in determining the result rather than manual calculation when involve a big data.
Implementation for preliminary study. In this study, we have done preliminary study in order to understand more on Dijkstra'S algorithm. We selected a small area in Seremban 3 residential area Negeri Sembilan to test the process of the Dijkstra'S algorithm. The calculation is performed manually. It involves 5 nodes as shown in the diagram, and the travel time is in minutes. However, doing a manual calculation is time-consuming and may lead to error in calculation because the actual data is big. Due to this limitation, the study will be extended in Microsoft Excel for actual data. The data of the preliminary study has been applied in Microsoft Excel to prove the accuracy in manual calculation. The result obtained is still the same as the manual calculation. Implementation for actual data. First, form a distance matrix from node A to node X and the two tables containing sequence of stop at every node and the total travel time by using sum, VLOOKUP, if and index function in Microsoft Excel for an easy calculation in finding the minimum travel time. Next, continue with the Excel solver. Set the solver to find the minimum and add the necessary constraint in the solver. Click the solver button to get the result.
After keying the data into Excel solver by following the steps shown in implementation section, the node will be linked to the nearest node in order to get the shortest route with minimum travel time. As a result, the red color determines the shortest route and its total travel time in minutes, which are from node C to node X and takes about 435 minutes or 7.25 hours. The route shown in the table will pass all nodes which satisfy the objective. As a discussion, it takes 7.25 hours to complete the collection task. The advantage of using one garbage truck is it reduces the management cost of hiring additional drivers, fuel and maintenance of garbage trucks. The disadvantage is it can cause the unpleasant smell and result in dissatisfaction from people living around the area.
Result obtained using this algorithm method for using 2 garbage trucks. For the garbage truck 1, the shortest route with a minimum travel time is starting from node C to node L, which is 228 minutes, and for garbage truck 2 starting from node M to node X with a total travel time is 186 minutes. Conclusion for this result: it takes about half of working hour to complete the task. Advantage using 2 garbage trucks is it can reduce working time, and with a reduction in working hour can help the workers mentally and physically. For disadvantage using 2 garbage trucks is it may can cause management costs to increase and the cost of truck maintenance will also increase. This is a comparison travel time between using one garbage truck and two garbage trucks. For the one garbage truck, take 435 minutes or 7.25 hours to collect solid waste at the residential area, while two garbage trucks only take 414 minutes or 6.9 hours to complete the task.
This study is about the application of Dijkstra'S algorithm in finding the shortest route for waste collection by considering a minimum travel time. The software used in this study is Microsoft Excel and Excel Solver. This study approached two cases in determining the shortest route with minimum travel time for waste collection, which is using one garbage truck and using two garbage trucks. The result indicates that the shortest route with minimum travel time for waste collection by using two garbage trucks have been fitted to our aim. However, it depends on the solid waste management companies to decide which method is the best for their company.
The recommendation for this study and future research is to find the efficient route with the shortest distance by considering any unpredictable events. Next, it is also suggested for future researchers to make a research of calculating the distance that is located at the same start and end point.